Right. Good morning, everyone. Good afternoon, depending on where you are in the time zone. My name is Utpal Bhatt, and I'm the SVP of Marketing at Qubole. And welcome to our panel today, Data Lake and Data Warehouse, Collision or Synergies. First of all, a little bit about Qubole. Qubole provides an open data lake platform to accelerate your data engineering, analytics, and machine learning initiatives. Qubole's end-to-end platform radically reduces the administrative effort and deployment time for various types of primarily data lake workloads, while our patented technology automatically cuts down the cloud costs for data processing by almost 50% compared to the alternatives. Qubole is used by over 200 customers, including Adobe, Oracle, and Acxiom. And today, I'm joined here by John Riewerts, VP of Engineering at Acxiom. Welcome, John. We're very happy to count Acxiom as one of our customers. And we are out here today to debate a very exciting topic. Before that, John, can you tell us a little bit about Acxiom and yourself?
Yeah, absolutely. First, I want to say I appreciate the opportunity from you and Qubole to engage in what I agree is a very interesting topic in our industry. Start out introducing myself. I'm the VP of Engineering at Acxiom, focusing on some very, very cool problems that we aim to solve at Acxiom. So a quick little bit about Acxiom. Share screen just real fast. Can you see the screen okay?
Yeah, we can see the screen.
Perfect. So I've got a couple of pretty marketing slides. You know that marketing would do this. No engineer would put such cool icons and colors on such a screen. So who is Acxiom? We help the world's largest brands understand consumers, unify marketing, and enable experiences that matter using data for good. I think that's can't be understated enough. I mean, we are a consumer-driven company. We focus on engagement with our consumers alongside our clients, and ultimately how to use data in a good, ethical way across a couple major, really talk tracks, if you will. First and foremost, personalization, actually in no particular order. Focusing on personalization, that ability to recognize all consumers in all different stages in the marketing ecosystem, and how we can have a really personalized engagement with any consumer along their journey in real time. Activation and engagement, like I mentioned, we're talking about reaching real people with the appropriate messages at the appropriate time. The combination of those three are what I see as some unique challenges that actually get right into the very discussion point that we're talking about today. And third, data-driven decision making. So, you know, it does not make sense. We live in a data-driven world, and we live in a world where data is not going away anytime soon. It's exponentially getting bigger and bigger and bigger and bigger. And so how best do we use that for really the benefit of our clients and the benefit of the consumers that they're trying to reach? Quick little bit about, I think it's worth, I put in this slide just for a quick little unique value add that I personally get the pleasure of doing, which is seeing use cases across lots of different industries. So personally, this is pretty fun for me because I get to see what happens in financial services. I get to see how we might leverage different use cases within auto or telecom or CPG or airlines, you name it. And so insurance, you name it. So it's a fun, unique position that I personally sit in, and that Acxiom as a whole sits in, that we really get to play and help our clients with a lot of different data use cases. We're a part of a larger global IPG family, focusing on our clients' brands, messages to those consumers.
All right, great, John. Thanks for that introduction. And this is exactly why this is such a great topic for you to talk to our listeners about, because not only is Acxiom supplying the platform, the data platform, to a number of industries, a number of your customers, that this architecture pattern that you have at Acxiom is getting used across a broad spectrum of industries, which makes this a very rich set of experience that you can bring to bear. Thank you once again. Before we get started, just a quick logistics. We have, in order to make this session interactive, we have a number of polls that we'll be bringing up during the course of this 45-minute conversation. And I also encourage everyone to use the chat option. We have folks on the Qubole team ready to answer any questions you may have. We will also curate some of those questions and then save some time for John to address those questions directly. A quick test on the poll. The first question is, let's see, which continent are you watching this webinar from? If you can take a few seconds to select the option that matches where you're physically located, that would be great. All right, I'm going to close the poll in 3, 2, 1 minute. Okay, there you go. Okay, we have predominantly North American audience. No surprise. This is primarily because of the time zone here. Anyway, so let's introduce the topic. This is near and dear to my heart. Over the years, we have learned how to collect all sorts of data. Today, we're collecting structured, semi-structured, and even unstructured data. We've also learned how to store this data that we are collecting in real time. Now, the next frontier is, how do we start using this data and getting the most out of it? Whether we are going to use this data for historical analysis, for discovering things in real time, and even predicting the future. And this is where John and I will talk a little bit about what are the right data platform choices to help you make the most out of the data that you're collecting. Once again, we'll make this very interactive. So John, let's jump right into this topic. But first, a little bit of your journey at Acxiom. Tell us a little about what was the architecture you started with, and at different forks, what were the decision points that led you to the architecture that you currently have at Acxiom?
Yeah, for sure. Good question. Acxiom started with its roots in what I would imagine a lot of companies started their roots in. Starting with SQL-based data warehouses, and those really solved a good problem, and they had a really good independent life for some time. I've got an interesting slide for those who are familiar with the ad tech and martech spaces. You will be aware of this diagram. And so, it's an interesting slide because it shows the marketing technology landscape. Now, what's interesting about this to me is exactly what you just said. There's an ever-growing list of tools that we continue to see, and our industry is no different. Earlier on, a SQL database might have sufficed for the vast majority of use cases. But as we've continued to evolve, the reality is this was actually the marketing technology landscape in 2011. From there, we've grown from 150 to 350 to 1,000 to 2,000 to 3,500 to 7,000 different companies really vying for this large market, because at the end of the day, this is what companies use to help get their message out and ultimately have the return on any kind of investment made. And really where we are sitting at today is over 8,000 different engagement points from a technology perspective that any one CMO could look at and go, okay, how am I going to put together, how am I going to solve my use cases for the particular needs that I have? What that creates is a fun, interesting little technology challenge that we have, which is to say, a SQL database that probably a lot of us have started with is ultimately not the answer and not the one tool solves all to this large landscape. And in reality, we really need multiple tools. And so, you know, I personally believe that there is not one tool to solve the entire world of problems. And we also have to weigh that with against the, you know, we don't want to bring in every tool for every little unique use case. And so it's an interesting dichotomy that we live in, because innovation in this realm is outpacing consolidation. We see this across, whether it's advertising, promotion, social relationship, commerce, you name it, the management platforms, the DMPs, DSPs, it's a massive ecosystem that we're dealing with. And so how do our clients ultimately solve the right problems with the right data at the right time across multiple channels becomes a challenge, and a challenge that supersedes just a SQL database. And so this is where, you know, you asked where's the architecture evolved into. I mean, just kind of the TLDR for Acxiom's story is that in order to enable our clients' use cases and activate our clients' use cases, we recognized that we needed to build a best of breed set of technologies to ultimately solve independent problems that I know we'll kind of get more deep into. But whether that could be that, hey, we need a place to start with just how do I get data into a consolidated view? How do I just forget the actual structure of the data, forget the intent and purpose of the data? How do I deal with the physics problem of getting the data into some kind of central logical location so that I can begin to data model off of that and activate different use cases that may then go into different technologies, such as document stores, pub sub systems, API-driven systems, you know, warehouses, you name it. So at the end of the day, what we have found is that it is not one technology to solve all. When you bring in multiple technologies, that does increase some complexity, but done right, you can get a lot of gain and a lot of dividends off of what we've architected out. And so I think, you know, to really kind of finish that out too, what we have seen, and I'm sure the listeners can relate to this, is that there also is no magical tool out there, whether it be at the app layer, the data layer, the compute layer, that just magically solves all this. At the end of the day, there is still a data engineering effort to think through how we approach these data use cases. Luckily, this is where Acxiom gets the pleasure of helping our clients ultimately achieve and activate those use cases through those data engineering exercises.
Got it. So John, I think we talked earlier about the three categories of benefits, where we talked about personalization, activation, and then decision-making processes. So can you help us with a couple of examples of use cases where and how this manifests in the Acxiom platform, and what is the underlying data architecture that supports that particular use case?
Yeah, great question. So, at a high level, more pretty architecture slides with cool icons. But yeah, I mean, you can break down those different use cases. I mentioned the first three. We kind of, from a technical perspective, break them, kind of see them in a different lens, whether it's analytics, audience engagement, or audience management, and then finally real-time engagement. Ultimately, from a technical perspective, most of the use cases fall within those realms, collaboration being a horizontal across those. And so here's a couple of quick one-word based use cases, or groups of use cases that we often deal with our clients. A couple, let's get down into the weeds type examples, and we could talk through the different technologies. It might be something, we could start with very traditional use cases. I have 20 different feeds of data. How do I get that 20 different feeds of data into a single data model that I can ultimately action and campaign against? Start with the most basic of use cases, right? So this gets into, okay, how do we link this data together? How do we build a brand identity graph that we can use to recognize these 20 or 50 or 100 different data types or categories of data that we can bring together to ultimately activate? So it might be a simple campaigning across multiple channels, which gets into multi-channel measurement. So my wife is a wonderful example. She'd probably not like knowing that I'm using her as an example in this, but I'm going to do it anyway. So my wife's a great example. She often gets advertisements via email. She will often look at those emails, click on that email, probably brought to an online store, which is now developing a click stream of her behavior. Then, she's actually very prone to going to looking at the reviews, reviewing a particular product, maybe even potentially adding it to a cart, and then a cart abandonment, leaving the cart, turning around, and all because she could probably drive 5 miles to the store that centered the advertisement and ultimately finally convert offline. So one of the fun challenges there is that little use case alone probably requires 9 to 10 different feeds of data to ultimately recognize the ROI of the initial email campaign or social campaign, wherever she got the ad first. And so how can we stitch all that together so that we can truly see the return on that initial campaign that was done that ended up as a cross-channel conversion that ultimately jumped across multiple channels? So, in that type of example, at Acxiom, we often start with a data lake. Quite frankly, just full transparency, this is where we leverage Qubole heavily from a compute platform perspective on top of shared storage services like S3. And so we might bring that data in. How do we then ultimately tie all that data together so that we can recognize that journey, that consumer journey across the different channels to finally recognize that conversion? Now, that might have occurred by doing particular, developing particular models around that data to infer that conversion, where we may be using some kind of modeling platform, or we may be tying this into ultimately reporting that we're going to be showing to a CMO to say, hey, here's your final conversion, or we're pulling in different third-party BI tools. these different use cases, pulling in these different third-party partners requires different underlying technology sometimes, because we all know that you can't just necessarily go to, tool A and say, hey, I need you to work with this underlying data technology. So the reality is we ultimately have to have a couple different best of breed tool sets to be able to ultimately enact that use case. Another one might be a financial services client who sends out an ad to sign up for credit card or something along those lines. And we might want to have a real-time engagement with that consumer, ultimately strengthening their or their journey as they're trying to identify the appropriate credit cards. Well, now this gets into, whether it be, 200 millisecond response times or often smaller, which requires, again, a different data technology, such as a document store like MongoDB or something like that. So whether it's, whether you're building initial campaigns and a client may have heavy data analysts who understand SQL, or you're working with different data scientists who understand, and plethora of different technologies there, languages there, Python, R, pulling in different frameworks like TensorFlow, you name it, tying all that together in a cohesive manner is the fun challenge. But at the root of that, this is where, in my personal opinion, this is where the data lake and the data warehouse have a really nice relationship between each other. And you can't, if you have more than one use case, if you only had one use case, then you may not need this, right? I mean, if you're just quite literally trying to solve a very simple use case with a couple of very simple data inputs or data feeds, you may not need this complexity. But the reality is the vast majority of us have more than one use case. And we have to, as engineers, consider what future use cases we may have in the future. And so that plays into, let's take a next best offer use case where a particular event comes in. We've got to make a decision right at that point in time how we want to treat that event to ultimately help the consumer on their journey in an asynchronous manner, and to make a decision on the next best approach that we're going to work with that consumer. That, while a transactional use case, then also has, we build up data, whether it be the event itself or exhaust from the subsequent offers, and we can absolutely apply analytics around that. So even a transactional use case ends up having a large volume of data that we could potentially leverage for the next use case or the next challenge that we want to take.
Yeah, I love the fact that it's the use case that determines the data platform, and if you have just one use of the data, you could engineer it differently, versus if you have multiple uses of the data, then you may want to look at a future and how you're going to use it in a different way. Great. So given that Acxiom has so many different ways of solving the use cases, how do you know you got it right? So how do you measure the success of the initiative? What are some of the ways to determine the ROI and feel good about mapping the use case to the underlying technology?
Yeah, good question. At the end of the day, we know we got it right when our clients know they got it right. I mean, that's kind of cliche to say, but it's the truth. I mean, we live for our clients to be able to say, okay, let me help you take that next best offer use case and go, okay, all right, let's break this down. We're going to have this amount of spend on this marketing effort. Are we translating to this, particular goal of revenue? that the marketing officer is ultimately attaining to attempting to achieve. So at the end of the day, not to make it overly simple, but it is that simple. We measure our success based off of our consumers and our customers and their success. Now, underlying that, there's potential, there's down in the weeds types of things that we can take a look at. Does it make sense to have the overhead of 30 different data technologies to solve 30 different use cases? Probably not, because now you're reducing your ROI based off of how much you're investing on. So, okay, great. Let's find a couple best of breed, if you will. Let's find a really performant data warehouse out there. Let's find a really performant document store out there, and we may be able to leverage those for different types of use cases so that we can ultimately have the leanest footprint of a platform, but be able to scale appropriately to not just the volume of the use cases, but the use cases, the variance in the use cases themselves.
Got it. That's great. In terms of a quick summary for our listeners, then it ends up being, at the end of the day, you need to deliver your stakeholder satisfaction. In this case, their end customers. If they're happy, I think you feel like you're getting it right. And then, of course, the economics of getting that right in terms of number of people, number of platforms you're managing, and so on. So that's that kind of is a great segue for us to get into our next segment, because this is a great setup for us as we hear about your own experiences working on a platform at Acxiom. What I would like to do in the next segment is lift it up a level. I know a lot of our attendees at the webinar are also grappling with the same types of questions. When do I use a data lake? When do I use a data warehouse? How do I know I got it right or not? But before we do that, we have a couple of poll questions. We have let's go through a couple of poll questions to see where everyone is in their journey today. If everyone can take 10 seconds to pick your choice. The question is, which platform are you using? Are you using a data lake, a data warehouse, or are you using both, or none of the above? All right, we'll close the question in 3 seconds. Or we did. All right, so almost 50% are using both, which is fantastic. And then we have another 26 using the warehouse and 13. Let's go with the next question as well, Ashley. How large is your current data footprint? All right, we can close in 3 seconds. All right, let's go ahead and close it. All right, lots and lots of data. We have almost 2/3 of our audience using upwards of 500 terabytes. That's great. So into the next section. The next section really deals with the industry as a whole. I mean, there's a raging debate going on right now on the use of a data lake versus a data warehouse. What is the footprint of a data warehouse in terms of use cases? And alternatively, what is the footprint of a data lake in terms of use cases? So the first question for you, John, is just net out the differences between the two architectural approaches for us. What is a data warehouse? What is it good for? Versus what is a data lake? What is the data lake good for? And as a starting point.
Yeah, I think if you were to probably search on the internet, you'll get several different variances of answers, but I think what most of those largely agree on is the idea that, you know, a data warehouse has helped us get to where we're at today. I don't think we can say that you know, we've never not used the other at some point in time. And so, you know, at the very crux of it, if you need to, if you need the speed and the optimization, and you know your data model as it relates to a very specific data model, it's a fully structured or pretty close to it, some semi-structured, but usually pretty fully structured data model, and you can narrow it down to that. That's essentially where you're at with a data warehouse. I think most often, I think you'll see a lot of papers associate this with SQL based warehouses as well. So, you know, a snowflake, if you will, where you have a SQL-based interface, heavily rooted in a really nicely well-defined data model. Where you see data lakes, this comes into the idea and the notion that get the data first, then declare the intent. And so, you know, let's just focus on getting data first. And that data may be unstructured. We may not, it itself may be structured, but we don't know the structure of it. And we don't necessarily know the particular context that we want to use it in yet. So it's the notion that, it's the recognition that data is ugly, and let's embrace it instead of hide from it. And so I think that's kind of where data lakes tend to live, is this idea that, I don't want to say wild, wild west, but it is the idea of democratizing different data sets for use, some of which may be structured, some of which may have a little bit more of a data model, some of which may have a little bit less of a data model. I think also too that you see is the flexibility in the use cases. So whereas, you know, if you were to put up against a high performance SQL engine with appropriate indexing and things of that nature, that's going to outperform for the particular data model and requests that model was set up to support. Now, if you need a just-in-time, you don't necessarily know what that use case is, and you need a lot of flexibility around potentially bringing in modeling technologies, or you're just trying to do data discovery. You need to understand what you're dealing with before you can actually activate it and use it. This is where the true flexibility of data lakes come into play. One of the things I like about this is that it's best. The nice thing about this is, and why I think both of them have a place, often in sometimes a single solution, is that competition is a good thing. We live in a wonderful world where you know, there are more potential offers of how we can structure data, compute against that data, organize that data, serve that data than ever before. And so whether we can, you know, at Acxiom, we often start with a lake because it's all about the idea of get the data in first, but then often end up either leveraging the lake itself for particular use cases, or funneling some kind of aggregate to that data, of that data to, you know, potential ODSs or potential OLAP or OLTP stores, if you will, to solve very particular use cases. So ultimately, there's a nice tie-in on the very theoretical definition of the two.
Great. I like the articulation of of the two in terms of structured SQL-based approach naturally lends itself to a warehouse, and that's where you're going to get the most efficiency and performance, whereas a newer kind of use cases that require the flexibility of data and more interactive data engineering will lend themselves to the data lake. In terms of, I saw a question someone posted in our chat as well, which is it's a great question, and I know a lot of our listeners are grappling with this one as the market gets louder and louder in terms of its drumbeat for one or the other approach and the overlap. What are some of the anti-patterns with data lakes and data warehouse? In other words, at what point, if you were to try using one for a use case that it's not meant for or suited for, what are some of the perils of doing that, and how does it manifest in from a practitioner's point of view?
Yeah, that's a good question. You're not going to like this very vague answer, but I'm going to give it anyway. Ultimately, I think it depends on the use case, right? So, a good example of an anti-pattern. If you know your model, if you know the model of data, and you know that in all likelihood that's not going to change, and that use case pattern is not going to change, maybe a data lake isn't right for you. Because you know your model, you know the data that you're getting, and you know there's not going to be variance. On the flip side, if any of those are false, I personally think then you may consider starting with a lake. The good thing is, especially if you take this in a public cloud approach, storage is cheap, right? I mean, at the end of the day, storage is cheap and can also be managed. The reality is, in my experience, to the petabyte size lakes, the vast majority of that data is for some deep archival purposes. And there's really only a small sliver of that data that gets actively worked upon. But at the same time, you may need that data for some kind of historical trend use case. And so, that's a great example of where to have something like a lake as a catch-all storage manner. Like I said, we base ours at the very base of it is on S3 or object storage. And the reason we do is because we've recognized that there are a bunch of compute platforms that can do a good enough job working directly with S3. So we have a physics problem, right? We don't want to ship data any more than we absolutely have to, which is another anti-pattern, right? Because we don't want to be duplicating data all over the place for every single unique use case. Like if there's only 5% gain on a particular query pattern by switching to a new technology, is a 5% gain worth it? So really the data of how the performance of activating those use cases can drive and should drive whether or not it's good to use a different technology. A great example, like I said, a high performance SQL warehouse, if your use cases are very specifically almost always tied to SQL, well, heck yeah, use that. Now, if you also have needs where you may have to you may want to pull in TensorFlow to do discovery or some kind of propensity model against that data, then, okay, great. There's alternatives that can give us SQL and can give us, those capabilities. But if the SQL has a particular SLA that it needs to be met because it's more operational in nature and it needs to, be under 200 milliseconds, maybe, SQL on top of a data lake may not make sense. And so this is, these are those back and forth that ultimately I've personally experienced that kind of have to weigh what is the right tool for the right job to ultimately get there. I think, as it pertains to, is it time to switch? Personally, I think if you're dealing, like I said, if it's a very known use case, maybe. But if you foresee additional use cases coming into play that are not just batch oriented as well, that could be transactional or streaming based oriented, then maybe not. It may be actually, as opposed to switching, it may be more appropriate to add, to complement the data lake with a data warehouse. And so, again, a good example that we often deal with is, again, a next best offer approach. So I've got an event coming in, that's a single record, some kind of event on a Kinesis or Kafka or pub subtopic that's coming in. We need to action upon it. We need something highly performant that's distributed to action upon that. But at the same time, we may want to keep that for later, whether that's for training purposes for a particular model, or we may contribute that to a data model that we ultimately expose into a warehouse. So just the idea that, what I've experienced at least, is if you have more than one use case and you have a feeling you're going to get more use cases, this is where the additive approach of a data lake plus a data warehouse comes into play. Within reason.
That's great. That's a really good way to summarize it. It's that, if you have one use case and if it's SQL only, high performance SQL, you know where to store that data. But if you have multiple use cases of or usages for your data, some unknown, then it might not be such a straightforward answer, even though the first use case might be SQL.
And if I could add one more thing, I was just thinking about,
sure.
Again, us as consumers of technology are getting to enjoy the fruits of everybody's labor, because there's high competition for you to have your data in somebody's technology. And so what we're seeing is we see a lot of technologies who are really making some great advancements over this idea that it can take on more than one simple use case. So you see these data warehouses that can now expand into more and more use cases. You see data lakes that can say, hey, I can get even more high performant, whether I'm bringing in Asset Hive or Delta Lake or something like that to help optimize data storage to eke out more performance. Or on the warehouse side, you see companies who are coming out going, I don't have to just use SQL. I could do other things too against this data. So, you see this kind of convergence coming from both sides. The cool thing about this is that we win, the consumer wins, because now we can start to leverage these different technologies where appropriate.
Got it. So on that note, John, then we have one more poll coming up. We just want to see, in terms of our audience, that where are they with regards to their data platform journey. So Ashley, do we have a poll question coming up? Okay, let's close in 3 seconds. 3, 2, 1. All right, let's see what the results of the poll are. Okay, similar sentiment. Majority of the audience is still looking at those who have added, looking at adding both into the mix. So this has been a fantastic conversation. I think we'd be remiss if we didn't kind of ask you to look into your crystal ball and predict where do you think these markets are going to end up. We have, as you point out, innovation happening on the data lake side, innovation happening on the data warehouse side. At least one could argue right now, it's still there is a clear kind of demarcation in terms of use cases, and the first use case for a particular piece of technology. But looking into the future, what are your thoughts? And also, as a practitioner, where would you like the market to go?
Yeah. You subtly mentioned a comment at the beginning that I think is so true. And it's this idea of past, present, future. Personally, I think we are at a point now, 10, 15 years ago, we were at a point of how could we take data and potentially reach a customer in the next month or the next week or the next day based off of that data. In the last decade or so, we've gotten to how can we reach a customer in the next 10 minutes, in the next 5 minutes. With predictive modeling that's taking place, what I often see is that it's almost like how can we future predict what you're about to do. And so in order to do that, you ultimately have to understand the past and understand behaviors of how journeys have happened to be able to predict that future. So what I see in the future is even more data, no shortage of that, but that data is driven by more and more and more event-based approaches. So as opposed to us deciding, hey, I want to target this large scale audience, it is continually, and it's not necessarily something brand new because it's been happening for at least half a decade. But how do I take events that are happening that I can glean to and predictively model where we could potentially help consumers make decisions. And this, I mentioned a lot of marketing use cases, but I think that this is across all sorts of industries. I mean, heck, look at SpaceX with rockets have been launched. I mean, the amount of modeling that has to take place to be able to predict just in time events as they're happening, as a rocket's being launched or as it's coming down, being able to predict that just in time requires that historical knowledge to be able to drive a future action or direction, whether it be for a rocket, whether it be in the automotive industry, healthcare industry. I mean, look at what we're dealing with COVID. I mean, we are constantly trying to take in data at real time. It started out by going, okay, let's all start aggregating daily. Now let's start aggregating monthly. This is a microcosm of exactly the evolution. Now it's like, okay, now can we potentially predict? Germany just released an app to say, hey, have you been exposed, or do you know anybody that's exposed, so that we can kind of predict, okay, geographically, how can we build models that show where potential exposure happens? These are all great examples of where more and more and more I see it evolving into predictive analytics to help shape a future, as opposed to, I don't want to say manually reacting to a past, but yeah, manually reacting to a past. Now, those machine learning algorithms require some sort of understanding of the past. So, you have to have that data set that represents the past to be able to predict the future at real time. So it's a nice symbiosis between batch and real time that's happening.
That's fantastic. Yeah, it's I think that we've figured out through BI platforms who have, that industry has matured significantly to use data to understand the past. I think we are at a frontier now where real time or streaming analytics and of course machine learning is becoming more and more prevalent, and it's definitely going to be something that we'll see at the same level of maturity as BI platforms going forward. So using the data to understand the present and using the data to predict the future. Great. John, this has been a fantastic talk. There's one question from the audience here that we haven't answered yet. So the question is that, how would you, what are your thoughts and how do you join data between a data lake and a data warehouse alternative, as opposed to just simply copying it there?
Yeah, great question. So at the end of the day, what Acxiom, what we leverage currently is Spark. And we don't think of Spark as in like a traditional Hadoop. We almost think of Spark as, we look to providers like Qubole, to really look at Spark as a service. It's a compute service. And so first there's a physics problem. If you have to do joins across two different locations of data, whether it be data lake, data warehouse, two different data stores, one might be a document store, one might be a relational database, one might be a key value store. What we have found is that ultimately we see a lot of value in leveraging Spark, which represents a distributed in-memory way of computing, to be able to read that data. First off, if there's any kind of pre-aggregations that we can do within the original platforms, let's take advantage of that compute, bring that into a data frame, and then ultimately leverage the joins in memory in a distributed fashion, leveraging Spark. The value that we ultimately resolve to is seeing Spark as that compute platform, almost like, I promise you, they didn't ask me to say this, but this is honestly the way we view Qubole. It's kind of like a Lambda for Spark. It's a serverless general approach to Spark. Spark is a managed service. And so that way we can increase, decrease the compute need in a just-in-time fashion to ultimately be able to do these joins. The three slowest things in any system: humans, network, and I/O, I/O to disk. Those are the three slowest things. That's I try to work fast, but I'll never work as fast as a computer. The other two are physics problems, and so by being able to have a platform that we can that has a high degree of flexibility, in terms of being able to read from different locations, disparate locations, including transactionally, pub subsystems, and warehouse systems, and be able to do that type of join appropriately, is why we've landed ultimately on Spark to handle the majority of the load. That's not to say all the time, but the vast majority, we use Spark to ultimately leverage that join within the data frame.
That's great, and I like the use of physics in this explanation, and I think and it's very enlightening, because at the end of the day, you're absolutely right. If there is data movement involved, then there is latency, there's performance hit, there's cost, all sorts of things. So minimizing, so not going against the physics of data movement, if you can achieve that sort of performance by keeping the data in place, is definitely the way to go about it. I'm going to remember that. So I don't see any other questions. So John, any last comments for our listeners?
We live in a fun time. As a data geek, there's a lot of different ways to solve problems. I think as we were kind of prepping questions, one of the last ones was suggestions on how we might approach and lessons learned that I've had. And it really does come back to a couple key things for me that I've learned is, one, don't over architect. You can over data model. You can bring in too many technologies. You can try to come up with the most optimized way to solve a particular minute micro use case, but it may ultimately result in a higher TCO when combined, total cost of ownership when combined with other use cases. So if it's 95% good enough, and you spend $600,000 in R&D to try to squeak out $500 a month of usage, that may not be worth it. So over-architecting sometimes is a reverse problem of having so many nice tools to play with. So sometimes good enough is literally good enough. I think also, it's, for me, it's been, I've been hit with this personally. Choosing the right tool for the right job requires you to know the job first. Jumping into saying, hey, I'm going to do a data warehouse, or I'm going to do a data lake, or I'm going to do a document store or whatever, without understanding what the use cases are first, often got me into trouble. I often would do that at times earlier on, and learned the hard way that really it's more important to understand the true use case and the acceptance criteria behind that use case, and then start evaluating the best tools. I think also cost is obviously a key component to this. One of the things that Acxiom learned early on, especially as we were going into the public cloud, is really lift and shift from a traditional data center to a public cloud is, I don't want to say is always a recipe for disaster. I'm sure there's a couple use cases where it's good, but more often than not, it does require some level of re-architecture. Now you got to weigh that over the don't over-architect. But one of the foundational things that we've come across is the separation of compute and storage. Because what we have found is that we can scale both of those independently very, very well. And we're actually seeing this in the industry where there's so many different tool sets, whether it be SQL-based tool sets, data lake-based tool sets, key value store-based tool sets, that are taking this notion on of separation of compute and storage that allows us to independently scale each of those.
Great. That's a great summary. So keep it simple. Don't over-architect or over-engineer it. Use the right tool for the right job. Let the use case determine what you should be using. And cloud does come to the rescue when it comes to scale. So
there's
great
one
point.
more I want to squeeze in there if I can.
Sure thing.
Separate data from context. Data coming in doesn't necessarily have a context of what you want to use with it. So separate the idea of getting data to a location prior to figuring out what you want to do with it, because in all reality, you're going to have multiple uses of that data. And so you never know what you may use that data for. So if you start with just getting the data in first and then figuring out what you want to do with it, it generally leads to a more positive outcome with that data.
Great. Excellent. Well, John, thank you so much. We're out of time. It was a real pleasure having you on this topic. And no, thank you so much. This was extremely informative. I learned a lot. I'm sure our listeners did too. Once again, thank you. And this concludes our panel today.
Hey, thank you. Really appreciate the time. Thanks everybody for joining.
Thanks everyone.